Hello everyone, welcome back to my channel, and today we are talking about the EIP 7594. So we open a official website of Ethereum organization, and I can explain this what is this EIP and how that work, and we went one and I want to walk you through everything exactly as it is written here, and but normal way so anybody can understand without getting a lost of cryptography or heavy consensus terminology. So this EIP introduced the PeerDAS, which stands for the peer data availability sampling. And the simplest way to think about peer in this, Ethereum wants a massively increased data throughout for rollups without forcing every node to download the full blob data. This is the most important part. So that EIP introduced. This is the limiting factor after EIP 4844. So blobs become a cheap, but the nodes still need to be downloaded, all of them. PeerDAS is fix these limitations, and so let's go step by step way an EIP page for that present information and how that work. So first we do about the abstract. Abstract is like a PeerDAS is a networking protocol layer, allows the nodes to perform data availability sampling, and ensures that the blob data has been made available while downloading only a subset of data. PeerDAS utilize the gossip for the distribution, discovery, and the finding peers of particular data custody and peer request for sampling. In here, abstract in short, but it hides a lot of complexity. Like a EIP says, PeerDAS allows not the sample only a subset of the blob data while still checking availability. Let's unpack what is really means here. When the blob contains a blob data, normally a node must download every blob and verify it. If the blob get large or we include the dozen of them, node bandwidth is explode. There's a hard limit to be Ethereum scaling. So PeerDAS is changes this by gossiping the blobs across a specific subnet, not a globally, and dividing each blob into a smaller authenticated shells, letting nodes download and a random selections of these cells using cryptographic guarantees to check integrity and availability without a full data. This sampling approach is the safe because of the underlying ensures the coding structures. So we can see like how that work. Here there is an initial state. So blob goes to the split into rows and the row 1, 2, 3, and they subdivide into the cell. Then cell grid is created and the final structure is the column sampling. So now that do the column sampling in the 7594. Then we goes to the motivation. Dash is the method of scaling data availability beyond the level of EIP 4844 by the not requiring all nodes to download all data while still ensuring that all the data has been made available. Here's the EIP says that Dash lets Ethereum scales beyond the EIP 4844. Why? Because rollups depend on L1 data availability, not executions. Execution is already moved off chain, but the rollup still needs to be post it compressed data to L1. If the DA is expensive, rollups can't compress more transactions. PeerDAS effectively makes a DA scalable. DA means the data availability. Then nodes download less. Here's all thing about the blob data. So I can explain with the blob data. So the nodes download the less blob data, and the bandwidth doesn't go with the blob count. Ethereum can add more blobs per block. This shifts the bottleneck. Before the every node must download like everything. And after PeerDAS introduced, the nodes download may be the 1/8 part, or later we have like after the scaling that goes to the 1/32th part also they can only download this much only. This is the entire reason this EIP is the big deal. So the specifications, we go for the specification now. We extend the blob introduce EIP 4844 using the one-dimensional ensures coding extension. Each row consists of the blob data combined with the erasure code. It's subdivided into cells, which are the smallest into that can be authenticated with their respective blob K2G commitment. So like here we can do this in the whole specification we do in the 4 parts. The first is like extending blobs using one-dimensional erasure coding. EIP 4844 gives us a blob, but PeerDAS takes each blob and add and ensures code extensions, turning into a row with redundancy. A row is equal to the original blob data plus the ensures code. This redundancy is the reason Ethereum can reconstruct the blob even when some data is missing. How can that go? We can see in the diagram. Here's the original data. The data block is there and that's split into the chunk 1, 2, 3 or like till the end. Then encoding process is there. Generate a parity. Parity 1 and parity 2. They goes to here some of the chunks and the chunk go to the complete row. Full row is equal to data plus parity. So this kind of that work. Then the second part is the subdivided into a cell. That means the smallest authenticated unit. Each row is the cut into the small pieces of called cells. Each cells can be independently verified using a K2G proof. This matters because nodes only not a specific from the specific columns. They don't need a entire blocks. They don't need a full row of either. And the other thing is like here the column. This is the core conceptual shift. The column is a vertical slice. A column is a vertical slice across all the same index. Imagine a 10 blob in a block, each becoming a row of 2048 cells. The column is the column is cell 0 from every row, cell 1 from every row till the cell n for the every row. So not sample these columns, not rows. Why columns? Because the columns let you sample across all blobs. Sampling rows would require node to reconstruct extensions during the block productions. Columns allows off-critical path encoding. This drastically reduces the block production load. The fourth one is the deterministic subnet assignment. So the nodes are deterministically mapped to certain column and subnets. Your node ID determines the which column you custody. This ensures the load balancing across the network. This is the where PeerDAS gets the peer like a part. You sample from the peers who custody the column you need. This is the whole part of like one point of what are the specification. The other part is like other thing is like here the node can reconstruct the entire data matrix. It acquires at the least 50% of all columns. If a node has been less than 50%, it can request the necessary columns from its peer nodes. Additionally, a limit 6 blocks per transaction it is introduced. Clients must enforce the limit when validating block transactions at a submission time, when received from the network, and the during block productions and processing. The detailed specifications are Ethereum consensus specs. Next one is like a 50% reconstructions rule. Why 50% do? The EIP states a node can like so the EIP states is there. So why 50% rule? The EIP states here like a node can reconstruct. This is the rooted read Solomon ensures coding. Ensures Ethereum uses the 1D erasure coding where the half the data is the original, half is the redundancy. If you collect any half, you can reconstruct full row. If you collect less than half, then you request for the missing column. This is why nodes only need a smaller number of sampling. Statically enough for the detect withholding. Then the limit for like here we also read about limit of blob per transaction, limit of 6 blob per transaction. So this is a guardrail. Without this, someone could craft a single transactions with 100 blob, forcing huge proof size. Validator must reject any transactions with the more than greater than 6 blobs. This keeps the peer proof predictable in a size. Next one is like a networking. So this EIP introduced the cell K2G proof, which are used to prove the K2G commitments, opens a cell for the Q1 index. This allows downloading only specific cells from a blob while still ensuring the data integrity and the respect to the corresponding K2G commitment, and it therefore the key component data availability sampling. So this is the most technical sections here for the networking. This EIP introduces a cell K2G proof. You already know the K2G commitment prove the entire blob. But the PeerDAS needs proof for the individual cells. Why? Because not sample cells, not full blobs. Computing all self proof is expensive. So the EIP pushes the cost onto the Blob transaction sender. This is a clever optimization. Blob producers verify proof in the cheap way, but do not compute them at like expensive. So, and we are understanding this wrapper. So transactions here, the RLP transaction payload body and the wrapper version, blobs, commitment, self proof, and self proof are self proof 0 to self proof 1, 2, 3 like. So in here, self proof is the contains proof for the every cell including extension cells. Blobs are not and the blobs are not sent extended. Nodes compute extension cell locally, and wrapper version is set 1 for the now. Then the verification step, how that verification that goes. Node must check number of blobs is equal to the number of commitments. Same number of blobs and same number of commitments that should be there. Self-proof count is correct. Commitment hashes match version hashes. Both the hashes also the same. All K2G self-proof match the computed extended blob. Most clients will use the batch verifications here. Then the next one is rationale. So why user dash to scale the DA layer? Because without dash, adding more blobs make node requirement explode. So PeerDAS keeps the node load constant and while increasing throughout. Why does the peer sampling provide? So massive redundancy. If one peer fails to give you a sample, you ask for another. The network becomes harder to attack. So that is like peer sampling providing. Why are these parameters chosen? Parameter of PeerDAS given the specs support network security while keeping node requirements sufficiently low. See the security argument below for the further details. Okay, why does this parameter chosen? So they are tuned to make attack extremely hard, keep bandwidth reasonable, allow future upgrades like a 1/8 or 1/16 or 1/32 sampling cost that is degrade. So why do validators have an additional custody requirement beyond the full nodes? Validators are already assumed to operate a stronger hardware. This is an extra custody stabilize the network sampling reliability. Then there is a column sampling versus a row sampling. What are the difference between them? Like in a column sampling doesn't require block producers to compute extension block. Allow pre-conceptions, reduce L1 block productions overhead, distributed load more evenly across peers. Then is a backward compatibility. This EIP fully backwards compatible with the EIP-4844. Block producers don't need to change anything except including self-proof. Then the test cases is there and the security considerations. The attack EIP-7594. In that security consideration, the attack EIP-7594 cares about the data withholding. A malicious block producer pretends blob data is available, but the hides part of it. So DAS prevents is because nodes sample randomly and to full many nodes, you must answer to full many nodes, you must answer all the random query. But answering too many queries leaks enough data to the trigger reconstructions. So the EIP includes the formula showing how improbable to successful attack becoming the network grows. With the 10,000 sampling nodes, even tricking a 1% extremely is unlikely. So here that you can see that for mainnet parameters, given the specifics of assuming a 10,000 nodes on the network, we can compute upper bounds of attack access for the verifying E. So there is a that much 0.1 to 0.05 and the target nodes is like this much and the upper bound you can see here. This table shows chances of successful attack quickly drop to negligible amount. So PeerDAS is considered the secure tool without withholding attacks. So here's the all about the EIP 7594, the peer data availability sampling. So I think that is understandable what I say. If you want a deep detailed knowledge about this, then you comment me and I can make a proper detail about that and explain about that. Goodbye everyone for now and we meet with the next new technical concept or topic.